Hello, am I audible? Mazia, Rahman, Shaifullah.
Yes, sir.
Okay. Have you completed the NCRT of probability?
I have 2 more exercises left, sir.
2 more exercises left. All right, Rahman, what about you? And Mazia?
So a few more questions.
All right, all right. Okay, so we are going to start trigonometry in today's class. All right. You know about trigonometry from class 10. There are 6 trigonometric functions: sine theta, cos theta, tan theta, cot theta, sec theta, and cosec theta. Right? If there is a right angle triangle, if this is the angle theta, this will be perpendicular. This is base, this is hypotenuse. Right? This is perpendicular upon hypotenuse, base upon hypotenuse. 1 minute. All right. Tan theta is p upon b. This is inverse of this. Sec theta is h upon b, inverse of cos theta, and this is h upon p, inverse of sin theta. Right? We know all these values. Three identities we know: sin square theta plus cos square theta is 1, secant square theta minus tan square theta is 1, cosec square theta minus cot square theta is, right? This all we did in class 10. So let's start with a simple question. Right? Try to solve one question. Give me 1 minute, all right? All right. Try to simplify this. Sin theta upon 1 plus cos theta plus 1 plus cos theta upon sin theta. All right. This is class 10 question. Simplify. I'll give you a few minutes.
So it is sin theta upon what?
This is sin theta upon 1 plus cos theta plus 1 plus cos theta upon sin theta. All right, how to solve this? Take LCM. So 1 plus cos theta into sin theta. Cross multiplying. This is sin square theta. This is 1 plus cos theta whole square. So see, this is sin square theta plus, if I open this, I'll be getting 1 plus cos square theta plus 2 cos theta. So that cos square theta plus sin square theta will get us 1, and this plus 1 plus 2 cos theta on 1 plus cos theta into sin theta. So this 2 and this 2, if I take that common, this is 1 plus cos theta upon 1 plus cos theta into sin theta. So this is cancelled. So we get 2 upon sin theta, and that is 2 cosec theta. This is the final answer. All right. This you have already solved in class 10. Please note it down. This is clear, Rahman?
Yes, sir.
Okay. Mazia, Alvia, Shaifullah.
Yes, sir.
All right. So after this, do you remember the values? Shaifullah, what is sin 60?
Root 3 by 2.
Root 3 by 2. Rahman, cos 30. Rahman, you are not audible.
Root 3 by 2, sir.
Root 3 by 2. Mazia, what is tan 45?
It's 1.
Okay. So I guess you all know about these values. So I don't need to write the table. All right. Now, what new thing we learn in 11th? First thing is degree measurement. All right. How degree is measured, or the angle is measured in degree. Whoever invented this system of measurement, what he did was take a right angle and divide it in 90 degrees. Right? Take one right angle and divide it into 90 equal parts. Right? Each part will be called 1 degree. But what is 1 degree? 1 degree is again divided into 60 equal parts. If you take each small division and divide that into 60 equal parts, that will be called a minute. All right, like 1 kilometer is 1000 meters. Again, 1 meter is 100 centimeters, and so on. Right? We are dividing angles into smaller and smaller parts. So each right angle has 90 degrees. Each degree has 60 minutes. Each minute has 60 seconds. All right. Is this clear, everyone? Rahman, Shaifullah,
Yes, sir.
Yes, sir.
okay. Masia, Alvia, all right. Masia, you are not audible. Your voice is not coming. All right. So,
Yes, sir.
all right. Let's start with the question. Express 90 minutes in degrees. You have to convert this into degrees. Simple unitary method. Use this conversion formulas and explain this in degrees. All right. This is the symbol for units. All right. 16 minutes can be written as this. This is 16 minutes. And if I write this, this is seconds. So how to simplify this? We know 16 minutes is 1 degree, right? 1 minute will be 1 upon 60 degrees. So 90 minute will be 90 upon 60 degrees. Very simple. This is clear. Rahman, Shaifullah, Mazia, Alvia.
Yes, sir.
All right. Express 30.54 degrees in degrees, minutes, and seconds. All right. In a simple way, you just have to remove this decimal thing. This is already 30 degree plus 0.54 degrees. So convert this in minutes. And if you again get decimal points, then convert them into seconds. All right. Try this one. I'll give you a few minutes. Have you solved it? Rahman, Shafullah, Mazia? Shafullah, are you solving this?
Yes, I solved.
Solved, all right. Let's see. So this we can write 30 degrees and 0.54 degrees, 30 degrees. If I convert this into minutes, I'll multiply by 60, and this is converted into minutes. So this is 30, this is 32.4 minutes. Again, I'm getting a decimal, so I can write this as 32 degrees, 30 degrees, 32 minutes, and 0.4 minutes. Again, if I have to convert this, so this is 30 degrees, 32 minutes, 0.4 into 60 minutes. So this is 30 degrees, 32 minutes, and this is 24 seconds. So this is the final answer in degrees, minutes, and seconds. Clear, Rahman?
Sir, how did you find degrees?
See, this was 30.54 degrees. I can write this as 30 degrees plus 0.54 degrees. Right, Rahman? So this I left as it is, only converted this decimal units into minutes. All right.
Sir, so degrees is 30 plus 0.54.
Yes. Just see this as a number. This is 30.54 degrees. So this number I can divide into two parts, right? 30 plus 0.54, right? If you have 12.5, you can write this as 12 plus 0.5. Same thing here. All right, Rahman?
Yes, sir.
Okay, note it down, everyone. Okay. So this is all about degrees. But in class 11th, 12th, and in further studies, we don't measure angles in degrees. What we do use is radians. All right. This is just a different measurement unit. All right. If you have to say in length, you can use kilometers like that, or even light years, right? There are different units. If you have to measure weight, right, you can use kilogram system, pounds, and etc. Same way, for angle measurement, we have radian system. All right. So write down the definition. The angle subtended by an arc of a circle whose length is equal to the radius of the circle at the center of the circle is called a radian. And this system, the unit of measurement is radian, and we denote it as small c. All right, write it down. All right, so what you do is you take any circle. All right, if the radius is r, you start from here, walk till a length of r, and this arc, which has a length of r, makes an angle theta, and this theta is 1 radian. All right, this theta is 1 radian. You walk to a length equals to the radius of the circle, and whichever angle is subtended at the center by that arc is 1 radian. So why this definition? This definition is used because this is same for all the circles. You take whatever radius circle, if you do the same thing, walk to a length of r, this angle is always a constant. That is why we use this as the definition of a radian. This is 1 radian. If we walk twice, then this angle will be 2 radian. If we walk thrice, 3 radian, and so on. This is clear?
Yes, sir.
Okay, Rahman, Mazia.
Sir, can you go up? I have one last line to write.
One last one. All right.
Yes, sir, done.
All right. So how do we measure or convert 1 radian into degrees? All right. We need a conversion formula for this. So how much is a radian in degrees? We know that in a circle, the angle measured at the center is directly proportional to the length of arc, right? If the length of arc is small, the angle will be small. If the length of arc is more, that angle will be more. This relation we already know. So if I take a circle and take two arcs, one which is at right angles, all right, let's name them AOC, and another arc which is at a R length, and let's call this point B. So we know that length of AB upon length of AC will be directly proportional or equals to angle AOB upon angle AOC. Right? This is very clear. Length of AB is R. Length of AC, this is quarter of a circle, and that is 2 pi R upon 4. This is equals to, this is the definition of 1 radian upon angle AOC is 90 degrees. So this R and R is cancelled. This 4 on there. So this is 2 upon pi is equals to 1 radian upon 90 degrees. Or you can say 1 radian is equals to this 90 into 2, 180 upon pi degree. Or you can say pi radian is 180 degrees. This is the relation we have, that pi radian is 180 degrees. Now, whenever you see any angles in degrees or radians, you'll be able to convert this into the other unit. All right, note it down. This is clear? Rahman, Shafullah, Mazia. Shafullah, is this clear?
Can you explain from the second part, please?
Second part, all right. This what I did in the second step, right? See, length of AB. We took the length of AB as R, this arc length, right? We walked till a distance of R. So I put the value of R. Length of AC. Naman, the derivation is not that important, but you might have to use this in some questions if they ask you about these questions. All right, you should know this proportional thing, that the length of arc is directly proportional to the angle. All right, otherwise the derivation in itself is not that important. Okay, Rahman, so length of AB is R. Length of AC, this whole perimeter is 2 pi R, and total angle is 360. If you take 90 degree only, then this length will be 1/4 of the original perimeter. So 2 pi R upon 4. Now angle AOB. This is the definition of 1 radian. If the radius is R, you take the angle measured by arc length of R, then this is 1 radian. So I substitute this value, and here angle AOC is 90 degrees. All right, Rahman, Shafullah.
Yes, sir.
Okay, note it down. All right, no, write down a few questions. Right, important angles in radians. And from now on, we'll only be talking in radians. All right, pi by 3, pi by 4, and so on. So convert this 90 degrees to radians. All right, convert 90 degrees into radian. Shaifullah Rahman, have you solved this? Mazia?
Yes, sir.
Okay. So how to solve this? 180 degree is pi radian. So 1 degree is pi by 180 radian. 90 degree is pi by 2 radian, right? So from now on, whenever you see pi by 2, that means 90 degree. All right. So please try to be familiar with this. Convert 45 degrees, 60 degrees, 180, 30, and 360. All right. Please convert all these angles into radians. And send the answers in the chat. All right. Convert all these values. All right. So 45 degree is pi by 4, 60 is pi by 3, 180 is pi, 30 is pi by 6. This is 2 pi radians. All right. This is clear, everyone? Mazia? Shafullah, Rahman, Alpia? Clear, right? Okay. Write down length of arc. If there is a circle with radius r and there is an arbitrary arc with length L, which makes an angle theta here. Theta is in radian. So how to find this length of arc? All right. Write down the definition. The angle subtended by an arc of length L at the center of a circle of radius r is given by theta equals to L upon r, where theta is in radian. And this is very important. You can only use this formula if the theta is in radian, not in degrees. All right. So if they are giving you the data in the format of degrees, the first step is to convert the angle into radian, then use the formula. All right. This is clear? Mazia, Rahman, Shafullah?
Yes, sir.
Okay. Let's solve one question then. Find in degrees the angle subtended at the center of a circle of diameter 50 centimeters by an arc of length 11 centimeters. All right. I'll give you a few minutes. Solve this one.
Sir, should we convert centimeters to meter?
No, you don't have to convert the centimeter into meters, just the angle in radians. All right. Are you solving this, Shaifullah?
Yes, sir.
Okay. Rahman, Mazia, Alvia. Rahman, are you able to solve this?
Yes, sir.
All right. Tell me when you are done.
So the final answer again we have to convert.
Yes, you have to find that in degrees. All right. How to solve this one? The length of arc is 11 centimeter. Radius is 25 centimeter. You have to find theta. So we know the formula. L equals to r theta. Theta is L upon r. So this is 11 upon 25 centimeter. But this theta is in radian. So we can convert this into degrees. So we know pi radian is 180 degrees. So 1 radian will be 180 upon pi degrees. So this much radian is t upon pi into 11 upon 25 degrees. So we can put the value of pi as 22 by 7. So this 7 will be coming here. This 2 90. We'll get this value. All right. This is 630 upon 25. You can simplify further and find the answer. This is clear, everyone? Shafullah?
So it will be pi by 180, right? For degree.
Pi radian is 180 degrees. So 1 radian is 180 by pi, right? We are converting radian into degrees, not degrees into radian.
Yes,
All right.
sir.
Yeah, the answer is in radian, right? Here, the value is in radian. So we have to convert this into degrees. All right.
Yes, sir.
Okay. Next question. Find the length of an arc of a circle of radius 5 centimeter, subtending a central angle measuring 15 degrees. theta must be in radians, Rahman. When using this formula, theta must be in radians. All right. After that, you can convert that into degrees and something else. But here, theta must be in radians. All right. So I have to find length. So L will be equals to R theta. Theta must be in radians. So let's convert this. So 180 degrees pi radians. So 15 degree will be pi upon 180 into 15 radians. L is equals to R is 5 into pi upon 180 into 15. This will be the answer. All right. You can simplify this. This is 36. So 5 pi by 12. You can further put the value of pi as 22 upon 7 and find the value. All right. Is clear, Shafullah?
Yes, sir.
Sir, pi we can put it as 180.
No. You cannot put this as 180, right? Because when finding the length, pi must be in radians. So this is pi radians. If you convert this into degrees, then this will be wrong. All right, you have to put the value of pi as 3.14 or 22 by 7. All right, Rahman? All right. Next question. A horse is tied to a post by a rope. If the horse moves along a circular path always keeping the rope tight and describe 88 meters when it has traced out 72 degrees at the center. Find the length of the rope. All right, try to solve this question. I'll give you a few minutes. Shaifullah, Rahman, have you solved this? Mazia? See, they are saying a horse is tied to a post by a rope and he is moving in a circular path. Alright. He had traveled 88 meters when subtending an angle of 72 degrees. So you have to find the value of R. So I have L as 88 meters, theta is 72 degrees. So if I multiply pi by 180, this is in radian. So this is 18 4s of 10, 4 pi upon 10 radian. We know L is R theta. So R will be equals to L upon theta. So this is 88 upon 4 pi into 10. The value of pi we can substitute 88 upon 4 into 22 by 7. So this is 7 into 10. So this is cancelled. The answer is 70 meters. Is this clear, everyone? Rahman, Shaifullah, Mazia.
Sir, in exams, can we keep as pi or should we simplify it?
No, if you have to find length, then simplify. All right. Don't keep them in pi. Rahman, they are asking length, not radius. See, they are not telling you that this is a circle. All right. Find the length of the rope. So that will be equals to R. Suppose this is the rope and he is moving in a circular path, that horse. Then radius will be equals to the length of the rope, right? This is the rope. So this way he'll cover the circular path. So radius will be equals to the length of the rope. Clear, Rahman? All right. Okay, so this is all about angles and how to measure them, right? No doubt still here, Shafullah?
No, sir.
Okay, Mazia, Rahman, Alvia, I hope no doubt still here, all right? So, sir, what was left in class 10th that we need to study trigonometry again, all right? So, what was the issue? In class 10th, we studied till 90 degree only, right? But trigonometry can be applied to any angle, all right? That is what we are going to learn in class 11. How we do that, how to draw a right angle, or how to find trigonometric values which has more than 90 degree values. All right. So what we use is circular system. All right. This is x-axis, this is y. If I take a point here, this is the angle if I need to measure. Then if this is theta, I can write sine theta as this upon r. This is y, this is x. So I can write y upon r and cos theta for x upon r and so on. If I take a point here and this triangle, this is theta, all right, but this angle is also more than 90 degree. This way we read the circular system, all right. So write down few things that we need to know before we go for this. sign of trigonometric values in different quadrants. Sign of trigonometric ratios in different quadrants. So if the angle lies between 0 to 90 degrees, all right, in the first quadrant, the angle is this 0 to 90. Here sine theta is y upon r, just as I told you before. This is theta, y, x, and this length is r. Sine theta is y upon r. Y is positive. Y is positive. R is positive. So sine theta will be positive in the first quadrant. What this means is, if you take any value of theta from 0 to 90, then whatever the value of sine theta, this will be positive. All right. For cos theta is x upon r. This is also positive and positive. The value is positive. Tan theta will be perpendicular upon base, so y upon x. So this is also positive because both are positive. For cot theta, this is inverse of this, x upon y. So this is also positive. Same for sec theta is r upon x. This is also positive. And cosec theta, r upon y. This is also positive. What this means is, if the value of theta is anywhere between 0 to 90 degree, then all the trigonometric functions will give positive value. Root 3 by 2, 1 upon 2, 1 root 3, 1 upon root 3, and so on. All right. If you remember, the values from 0 to 90 degree all were positive. So this is what we are learning. If the angle is in first quadrant, that means 0 to 90 degree, all the values will be positive. This is clear? Shafullah, Rahman, Mazia.
Yes, sir.
Okay, I write it down. All right. In the second quadrant, x is negative, y is positive, right? In the second quadrant, y is positive and x is negative. So in here, sine theta is y upon r. So y is positive, r is always positive. So this is positive. Cos theta, here x is negative and r is positive. So this value will be negative. For tan theta is y upon x. Y is positive, yet x is negative. So the value will be negative. Same for cot theta. This is inverse of tan theta. So negative. Sec theta is 1 upon cos, that is r upon x. This is also negative. And cosec theta is r upon y. This is positive, inverse of sine. So in second quadrant, sine theta and cosec theta give positive value. What this means is, if the angle is from 90 to 180, if someone asks you sine 135, cos 120, tan 145, and so on, these angles are from 90 to 180. In these values, only sine theta and cos theta give positive values. The rest of them give negative values. All right, this is clear.
Yes, sir.
Okay, note it down. All right, in the third quadrant, that means from angle 180 to 270, we know x is negative and y is also negative. So in here, sine theta is y upon r. So this is negative upon positive, so negative. Cos theta is x upon r. This is also negative. Tan theta is y upon x. So this is negative, this is also negative. So in total, we get positive value of tan theta. Same for cot theta. For sec theta is inverse of cos. So this is also negative. And cosec theta is r upon y. This is also negative. So in third quadrant, tan theta and cot theta give positive value. So if the angle with theta is from anywhere between 180 to 270, all of the quantities negative values except tan theta and cot theta. All right, note it down. All right. In the fourth quadrant,
Sir, can you scroll up?
all right. All right, tell me when you are done. All right.
Yes, sir.
All right. In the fourth quadrant, from angle 270 to 360, x is positive and y is negative. All right. So in here, sine theta is y upon r. So this is negative upon positive. So negative value. Cos theta is x upon r. So x is positive, r is positive. So value of cos theta is positive. All right. tan theta r y upon x. So this is negative cot theta x upon y, negative sec theta is inverse of cos theta r upon x. So this is also positive, and cosec theta r upon y. So this is negative. So in fourth quadrant, cos theta and sec theta give us positive value. Everyone else give us negative value. All right, note it down. All right, note it down. Rahman, Shaifullah, Mazia.
Yes, sir.
Okay, so you don't have to remember this in this long method. Just remember this one: A S T C. All right, say this 10 times and you'll remember this: A S T C. What A means is all positive. S means sign positive. So if sign is positive, cosec is also positive. T means tan positive. So if tan is positive, then cot is also positive. And C means cos positive. So cos theta and sec theta are positive. All right, why that happens, we studied here. This is very important to remember. All right, very, very important. In which quadrant, which values are positive and negative. Yes, Rahman is saying very good statement for this. All students take coffee. You can remember this in this way: all students take coffee. All right, this is clear, everyone? Shaifullah, Rahman,
Yes, sir.
Mazia. All right, and this is really important to remember, otherwise trigonometry will be very difficult for you if you don't remember in which quadrant which values are positive and negative. Okay, moving on. Write down angle measured in anti-clockwise direction will be taken as positive. Angle measured in clockwise direction will be taken as negative. What this means is you are standing here. If you calculate the angle in this way, then this is positive angle, positive 60 or 90, 120, and so on, like 235, 315, and so on, positive. But if you measure in this way, this is minus 60, minus 20, 120, and so on till here. So you can measure the angles in any direction, but preferred way is positive one. All right. So if they say minus 120 degree, then you will reach here. All right, you will move in clockwise direction if the value is negative. So how to deal with negative trigonometric angles? Note it down, please. Done. All right. Trigonometric ratios of negative angle minus theta in terms of theta. All right, we have to do something to remove the negative sign. What happens in if we have sine of negative theta, this we can write as negative of sine theta. All right, what this means is if you have sine of minus 120 degree, you can write this as minus of sine 120 degree. If you have sine of negative 30 degree, you can write this as negative of sine 30 degree. All right, so if you have minus sine theta, minus theta in sine, then you can write minus sine theta. All right, for cos eats the negative sign away. If you have cos minus theta, that is equals to cos theta. Cos is unaffected by any angle. What this means is if you have cos of minus 45 degree, this will be equals to cos of 45 degree. All right, you can just simply remove the negative sign from any angle that is in cos. All right, for tan theta, tan of negative theta, this is negative of tan theta. All right, take the negative sign outwards of the angle. Same for cot of minus theta is minus cot theta. For cosec theta, cosec minus theta is minus of cosec theta. And for sec theta, sec also, because it is inverse of cos, it eats away the negative sign. You can write simply sec theta. Is this clear, everyone? Shafullah, Rahman, Mazia, Albia.
Yes, sir.
Okay, noted down. All right, few questions. You just have to tell if the values will be positive or negative. All right, if we give you sine 120, cos 220, tan minus 45, cot, let's take minus 150. All right, you just have to tell if the final value will be negative or positive. I don't need the exact value. All right, Shafullah, Rahman, Mazia, this is clear or not?
Yes, sir.
Okay, I'll give you 2 minutes. Very easy questions. All right, Shafullah, have you solved this? Rahman, Mazia, Alvia. All right, let's see. Sine 120 is in which quadrant? 120 degree will be in the second quadrant. In the second quadrant, sine is positive. Cos 220. Where will 220 lie? In the third quadrant. In the third quadrant, cos is negative. Tan minus 45. So I can write this as minus of tan 45. Tan 45 means first quadrant. So this is negative because of this minus sign. Cot of minus 150. So I can write minus cot 150. 150 is in second quadrant. In second quadrant, cot is negative. So the final value will be positive. All right. Or the other method to solve this is tan minus 45. So minus 45 is in fourth quadrant. In fourth quadrant, 10 will be negative. Cot of minus 150. Minus 150 means you move clockwise to, you will reach third quadrant. Third quadrant, cot is positive. All right, 2 ways to solve this. This is clear, Shafullah?
Yes, sir. Clear.
Okay, Rahman, Alvia. All right, note it down. All right, this is all for today's class. In the next class, we are going to see how to find different values. All right, Please revise all this. All right, see you in the next class.